Welcome to the Rack Inspections webinar. My name is Zara McMahon. I'm the Office Coordinator of Safety Action, and our facilitator today is Gary Rowe, the CEO of Safety Action. Gary is a qualified civil engineer and Fellow of the Institution of Engineers Australia. Previous positions include Safety Engineer for Department of Agriculture, Structural Engineer, and Risk Manager. Today, Gary is going to explain the importance of conducting rack inspections and provide some tips to do them effectively and efficiently. Hi, Gary.
Good morning. Thanks, Zara. Rack inspections. What I'd like to cover with you today is the duty of care and the safety law that applies to racking and rack inspections. The important question of why we do rack inspections at all. And I want to share with you some special features of modern thin-walled steel racking and why they behave the way they do, and why safety inspections and regular inspections of the racking is more important than many other structures that you'll find in the workplace or indeed at home or in other locations. And I'm going to finish off with some tips to help you do some visual inspections. So let's look at the general duty of care. You'd all be, if you work in the safety area, very familiar with the 4 key points that the employer's general duty of care. 1, to provide a safe workplace, safe tools and equipment, safe systems of work, and that workers are trained and supervised. So where does safe racking fit into this? Primarily number 2, that there is safe tools and equipment. So part of the equipment and plant in the workplace includes the racking that you have. If there's a problem with the racking, it could, for example, if items were to fall off the racking or the racking were to collapse, that might affect number 1, that there's an unsafe workplace, therefore not a safe workplace. We need a system of work for inspections, that's part 3. And we need to train people so they can actually do these rack inspections effectively and efficiently. So I'm going to take you through these parts. So why do we need to inspect racking? Let's just have a look at some recent incidents and issues with racking. If you look a little bit closer at this scene, you're looking at some new cantilever racking that's only just been installed in one of our clients. And by first appearance, this looks high quality, very new, very good condition. But as we zoom in with the camera, you might observe something that's not quite right. And you might just see a hairline crack. I've now got the arrow showing you the crack that's appeared here. And if we look even closer, you can see that that crack has extended up and over the top of that cantilever arm. What we found in this particular case, that multiple arms out of the same batch were affected. So we actually had, our client had received a faulty batch of brand new racking. So there's an interesting point here that you can't assume just because you've got new racking that it will be safe and free of faults. Clearly the manufacturer was advised of this. We determined that the welds were not full depth. This was a manufacturing fault. So the steel itself was satisfactory metallurgically, but the welding technique was substandard for this particular batch. And the client received a total new batch of racking, which was in fact met the correct standard. So just something interesting to watch. What you're looking at now is a recent collapse, or in fact some years ago now. It happened in, this is the compound area of a manufacturing business in Port Melbourne as it happened, so back in 2010. And this is the aftermath of a collapse of a section of racking. And you'll notice there's not much storage actually in this section of racking at the moment, and I'll explain why in a moment. But the first thing to understand is that it collapsed with essentially only one pallet load onto the rack section that collapsed. So in fact, the racking was not fully loaded. So, and I'll explain the reasons why this occurs shortly. Here's some details of what the carnage from this particular rack collapse, and you can see how extensive the damage to the steel columns and beams were in this case. And we were very fortunate with the company involved that no one was in the immediate area. The forklift driver was within the safety cage of the forklift and didn't sustain any injury. So this was a very fortunate learning experience. So let's continue the learning experience to actually understand a little bit more of what happened here. Interestingly, this is one of the few cases in my work experience and long experience as a safety engineer where we've been able to look at the photographs both before the collapse and after the collapse. So here we are on the 11th of August, 5 days before the collapse, and you'll notice the arrow on the left pointing to a slight bow in the vertical column. The blue vertical column there is only just slightly bowed. If I didn't have that arrow there, you might not have noticed it. The photograph on the right shows a slight flattening of that blue vertical column in the middle. So it had been bumped probably by a forklift placing a load into the racks sometime previously. And the reason the racks in this area are empty is because that bow and damage to the rack was correctly observed by the local team, and correctly they followed the procedure to unload the racks on each side of any damaged section. So this is the correct practice in good best practice racking and logistics businesses. So they've followed the correct procedure here. So here's the scene on the left on the 11th of August, and here's the arrow showing going through 5 days later. So what actually happened? They unloaded the racking, as I explained to you, which was the correct process in this area. What they failed to do was to immediately tag out the racking so that anybody else coming onto shift or on a different day will not miss the damaged section of racking and start loading the racking up, which is exactly what happened 5 days later on a night shift. So with poorer lighting at night, the forklift driver looking for somewhere to place a load came across an empty section of racking and thought he was very lucky. He's found some gaps in the racking that he can place his load, and he was only placed one of those loads onto the rack to see the damage that you see here. So the lesson from this is not only do you need to do inspections, you need to be equipped, you need the danger signs, the danger tape, and possibly witches' hats to immediately tag any unsafe racking out of service immediately. And this needs to be an important part of your procedures. And we'll come back to the procedures shortly. So I mentioned earlier, what are the features of thin-walled steel racking and why do they behave the way that they do? I'm going to carry out a demonstration for you here, and I'll pull back a little bit from the camera, and I want to use a 1 meter measure here, as you can see here, which is a typical spirit level that we might use on a construction site, and we often use these during inspections of racking as well. So you might want to go to one of the hardware stores and buy a 1 meter spirit level with a tape measure you'll see on one side of it. I'm using it for a different purpose here though. I want to just show you what is different about thin-walled steel racking. So if I come back here and I come near, let's assume this is the vertical column, and now we have the beams coming out of each side of the steel columns. And let's say typically we have 2 pallet loads on each side. So of a beam that would normally be much longer out each side would have 2 pallet loads. Let's assume each pallet load is a ton for simplicity. So if I have a ton here and a ton here, I now have another column out this side. So 1 ton carries over to this leg here, to this section of the column. And if I have another load of a ton here, that brings a ton load down to this section of the column. So near the top of the racking, at the top layer, we have no load in the vertical section above. That's only there for bracing. We have 2 ton total, 1 ton from each side, transmitted down to the column at this level. So now let's go down one more level. So let's assume we have a 1 ton load and a 1 ton load at this level, transmitted to this column. We now have 2 tons from above, plus another 2 ton here. This section of column is now carrying 4 tons. If we continue this, and I can come down, I'm now holding the column up so to demonstrate, we now replicate 1 ton once again. We're now adding another 2 ton to this leg, but with the 4 tons from above, this section, which is the base of your typical racking, is now carrying 6 tons. What I'm trying to demonstrate to you is the importance of looking for even small bends and damage in steel racking. The part that is most commonly damaged in an accident when a forklift crashes into a piece of racking is in fact at the bottom. This is the section carrying the most load, 6 tons. So this is in fact the most critical section of all of the columns. The bottom of the racking is that you need to pay the most attention to, and why. So now we know the most important section. I'm now going to show you something else about steel racking, thin-walled steel racking. So if I can just hold this up, so here's obviously a plastic ruler, and you can see here it bows very easily. So if I apply a little bit of force, I'm just trying to get this on camera, you'll see that it bows very easily. And what I can show you that if I actually don't grip it in the middle, but just apply a little bit of force to this, I'll just tilt my camera down if I may. We might see this on the desk. So now I'm going to apply a similar load, but I've got my fingers either side, but they're not actually gripping it. They're just stopping it from bowing out. Now when I push, you might notice something different happening here. I'll just pull this out a little bit further so you can see it on camera. But what you'll see is that the bowing is now making an S shape. So it's making an S shape. So when you put bracing on a column, instead of bowing one movement, it has to make an S shape like this, and it's much harder for a column to bend in an S shape. So what bracing does is it doesn't provide any extra steel to carry vertical load, but it stops a vertical column from buckling too easily. The moment they buckle, they lose all of their ability to carry vertical load and they collapse. So I put a very small amount of load and that bows out very easily. So when you see racking and you see bracing and beams, and in fact the beams are not only to carry the load, they form part of the bracing. And we've seen some people say, I don't want that beam, I want to put a bigger load in here. What they've actually just done is taking some of the bracing out for the columns, and the columns are now more likely to bow out, lose their capacity to carry that vertical load. So the feature with thin-walled steel racking is different to timber beams, mild steel structures that you and I see all over the place, maybe your own home. If we overload the roof or the floor beams, they will sag over many years, sag slowly till they reach the ground, but they rarely collapse suddenly. So you can go out in the countryside to farms and you'll see sheds leaning over, and they'll just slowly lean over until they rest on the ground. We don't see this with steel racking. So steel racking is either upright and solid and carrying load, or if it has a buckle, it will immediately collapse like a rat trap. So in fact, the bracing is critical. And in fact, the fact that there is no bends or bows or damage to the racking is really critical for thin-walled, high tensile steel racking, which is very different to most other materials you and I experience, as I said, either in the workplace or even outside of the workplace, in our homes, etc. Bear with me, there we go. So thin-walled steel racking, this is the importance of it. So let's just look at a suggested rack inspection regime. And I'll share with you, I think, the best way we can go about this. Number one, of course, every competent business has a a hazard reporting system. So we advise our staff immediately that you spot any damage to the racking, even minor little bends, and they might not think it's very much. It's critical for us, and I'll show you the importance of this and the tolerances shortly, to report any damage immediately. Next level, I think a weekly walkthrough check, looking for obvious damage and incorrect rack usage. And I'll show you what incorrect rack usage is when we go through the checklist I'll share with you in a moment. On a monthly basis, we believe there should be a formal rack inspection using a checklist. And the people who use this checklist will also need some training along the lines of what we're covering today to be able to do this. And finally, there should be an annual audit by an independent specialist. This could be your rack supplier or a qualified engineer who comes and does an independent review on an annual basis is recommended to sign off, and that's in accordance with the Australian standard for steel racking that you'll have this annual audit. So there's an example of a plaque where a firm has inspected the racking and indicating 1 year, 12 months hence, it's due for its next independent inspection. So let's look at the weekly walkthrough. One or two people could walk down all of the rack aisles, look at each of the ends and the rear of the racks where they're accessible. What they're looking for is out of alignment. You can look down the line of the racking and it should all be perfectly in line, perfectly vertical, and the horizontal beams perfectly horizontal. We're looking for obvious deformation or damage. So we don't need a ruler here, we don't need a spirit level. What we're looking for is what the eye can see. So this is the weekly walkthrough. It's a quicker, easier type of inspection. We're looking for missing safety clips. I'll show you a visual of what they look like shortly, and incorrect storage practices. Excuse me. So a sign-off could look something like the date that it was done, who was the individual or persons who did the walkthrough check, and if they were assisted by somebody. So you would only have one of these per week. So in fact, this sheet may cover many months of inspections to just show that we have a history of looking at our racking formally at least weekly, but in fact, it's a fairly quick check that we're doing here. So now let's look at the monthly rack inspections, which are more detailed. So I'm going to show you a checklist for the main type of racking, pallet racking, cantilevers, and A-frames in this particular session. So let's look at pallet racking first. So here is over 2 pages on the one slide. And when we send out the slides after this session, you'll get a more detailed look at these checklists, or you can call us and ask for a copy if you like. So I'm going to go through each of parts of this checklist, so don't worry if you can't read it on the screen at the moment. So we'll go item number 1, the manufacturer's plaque to be displayed on each set of racking. So the Australian standard requires that a plaque like this be displayed showing the safe load limits for each level, shows who was the manufacturer, the date it was installed, and any other features of the racking or safety rules. In addition, the sign is to be corrosion resistant, lettering of a certain height, mechanically secured about 2 meters above floor level, i.e. about eye height, the manufacturer's name, installation date, the maximum distance from the base plate to the first and second beam, and any specific rules. So the plaque note, drawings of as-built racking must also be provided by the supplier with any specific limitations or different configurations allowable as shown on the plans. I'll show you a set of those shortly. So let's have a look at number 2. Is the racking correctly aligned? If we look behind the beam, you'll see the gap here on the slide is very equal between the column and the beam. So this tells me that this is correctly aligned. If you've got the spirit level, as I've explained earlier, you can place this on the beam, you can place it on the column as well. So we want all components vertical and horizontal. We want connectors to have even gaps. We don't want to overload any of the beams. So the Australian standard indicates that the maximum bending tolerance of a beam is to be the length divided by 180. So this is a straight, easy calculation. So most normal pallet racking will be something like 2.69 meters long. Divide that by 180 and it gives you 15. That means the maximum bow that would be allowable, so if I put a straight edge on that and I bow that down, would be 15 millimeters at the middle. So we could actually, there's a little bit of bowing allowed under load, but when you take the load off, that should spring back to horizontal. So we shouldn't have permanent deformation. So each beam needs to have the safety clips in place, and this slide shows you an example of one proprietary type of safety clip that will actually stop the beam from accidentally being lifted up, possibly by a forklift, lifting up the load underneath and taking it out and bumping it out, that beam out of its connector. So they need to be correctly connected to the uprights, and you'll see in this photograph that there is like little teeth on the connector from the beam that goes into the holes in the columns of the racking. So what are our tolerances? If we look at a vertical column, what tolerance are we allowed to have by bending for it to be out of specification? So what this slide shows you here, we can have 5 millimeters bowing to the side and only 3 millimeters end on, looking into the racking. So looking into the racking, 3 millimeters. What I can share with you is that if you can see a bow or a bend in a vertical column of a steel racking with your eye, then it exceeds those tolerances. 3 millimeters is incredibly small over a 1 meter gauge length to detect 3 millimeter bow. So a visual inspection can very quickly tell you whether this meets the standard or not. It just so happens having the 1 meter spirit level ruler and a tape measure, you can confirm what the dimensions are for your particular piece of racking. So splices. You'll see here in the photograph at the bottom of this slide, a piece of metal which is bridging 2 pieces of vertical column. So the rules here are, we prefer not to have any splices. We want columns to be, instead of cut and spliced, we want the full 1 piece of column continuous with no splice, for example. If we are going to have splices, they must be above the first beam and not below 1.5 meters. They must be fully secured. That would be at least 4 bolts, but there could be a lot more. The uprights need to be correctly aligned and not slightly offline, and only 1 splice per bay and obviously undamaged. Rack bracing. You'll notice in this slide some grey unpainted steel on the left-hand side of your slide at the back of the racking, and on the right-hand image, which is the bracing between the columns. And most people would say, I don't know if I have the right bracing or not. And that's where you need to turn to the supplier drawings, and they will show you what bracing was there when they originally installed the racking, and that should have been maintained over many years. So that's the only way you'll know whether you have the correct bracing in your bays. The bracing has a higher tolerance than the columns, and it has up to 10 millimeters, can be over a 1 meter stretch, so we can have a 10 millimeter bend, but no more. Here is an example of the manufacturer's as-built drawings, showing you how many bays, how many levels, and where the bracing is, and how much bracing. And I've added here in hand-drawn, in this case, the base plates, and I'll come to base plates in a moment. And the reason for this is the Australian standard has been updated more recently since this drawing, and is now given specifications for 2 bolts per base plate, and I'll come to that. So Every base plate should have at least 2 bolts. Most base plates have 4 holes in them, and a lot of people think, do I have to put a bolt in all 4 holes? The Australian standard is quite clear, at least 2 bolts per base plate for each column. They're to be secured and not sheared off or bent. The base plate is to be flat on the floor. The base plate weld is not to be cracked. And if there's packing under the base plates to keep the racking on a spirit level, horizontal and vertical, you cannot use timber because that'll rot away. You need to be steel or concrete. So the upright protectors. You'll see in this photograph some orange protectors are in front of the columns down at the ground level. I've already told you earlier why it's important to protect the columns at ground level, because they're carrying the most load. So in the analogy and example I gave you, the top part of the columns were carrying 2 tonne, then 4 tonne, down to 6 tonne. So each of the columns in this photograph notionally could be carrying 6 tonnes each at the bottom. I've indicated to you that when they're carrying high load, if they're not protected, they can bow out very easily. So what a column protector does is it doesn't have to be set into concrete in front of it as a crash protector. What they do is, if we look at this column and I touch it, it bends in the middle very easily. If I actually connect this not into the ground, but to the vertical column, so I've now got a more rigid protector, which is another ruler in this case, and now as I try and poke the column, you'll see here in this way, it won't easily bend. So all it's doing is adding some rigidity to the vertical column. It is not actually setting it into concrete in the ground, preventing a forklift from striking it and shearing it off. If a heavy vehicle like a forklift strikes a column of a piece of racking at high speed, then no protector will stop the rack from being collapsed. So we still have to have drivers operating sensibly within our rules and obviously trained and disciplined to operate correctly. So now let's look at good use of racking. So the photograph on the right here shows a type of pallet, typically from Europe or Asia, which is not to the Australian standard, and they don't have the piece of timber at each end of the pallet that locks onto the front of the beam. So we should have a timber part of the pallet at the front, a beam that locks it in, and that prevents the pallet from sliding off and dropping down through the beams. The photograph on the right here shows somebody's recognised they've got a large bulk bag and they know they've got a damaged pallet, so they've used 2 pallets. However, the damaged pallet there is not acceptable, and that load should not be in a rack in the form that you currently see it. So let's look at cantilever racking. Very similar now to what I've explained with the pallet racking. We have a checklist the same, and I'll take you through each of the key parts. Oh, I do apologise. So the manufacturer's plaque is very similar. The racking correctly aligned, once again, we can look down the aisles and down the rows of the beams and see that they are horizontal and vertical. We're looking for good condition, no cracks in the welds. I've shown you an example earlier where that can occur. The base channels are not damaged, and you'll see in the photograph here, there's a bow in the base channel. Although as bad as that bow looks, we can do a structural inspection and probably determine that that could be reasonably straightened without being fully replaced. We still need the base plate bolted down securely with the bolts, the racking not overloaded, so we'll have the safe working load placarded either on each of the arms or on the placard at the end of the pallet racking, the cantilever pallet racking, to show what the load is for each arm in that set of racks. The arm connections to the uprights, you'll see here is an example with yellow arms, and we have a silver pin here, which is a locking pin to prevent that pin from falling out and the arm coming off. So every arm has to have a safety clip to ensure that that cannot happen. The arm's in good condition, so we need to look for any arms that are either bent or twisted. And you can see some examples here where some of them are twisted, and the product stored correctly so that it's not likely to fall off. In this case, you'll see shrink wrapped loose items to minimize the risk here, although the above load is not acceptable because of the manner in which it's stored there is a bit precarious. So let's look at A-frame rack inspections. So here you're looking at a typical A-frame against a wall, which storing long sections typically, and in a vertical form. So one, structurally sound, no excessive corrosion, not cracked welds or bent components, not liable to tip over, e.g. bolted to the wall or floor, and chains to hold the material into the racks so that they won't fall out. A toe board, typically, you'll see the photograph on the left shows some material sticking out towards the walkway because it didn't have a toe board, whereas the photograph on the right shows a toe board which contains some material. We don't want any protruding items out into the walkway. People can get lacerations. And signage for any rules that you have. For example, in this case, with sharp metal that's being handled, to wear gloves in this case is what the company has required. And with that, we'll answer any questions that you have when we send out the slides following this webinar. Thank you very much for attending. I hope you learned something about the importance of doing rack inspections and also picked up some tips to do your rack inspections better. And with that, I'll hand back to Zara. Thank you, Zara.
Thanks, Gary, and thanks everyone for attending. We'll email you a copy of the slides shortly with Gary's response to any of your questions. Visit our website safetyaction.com.au to view and register for our upcoming webinars and training. Thanks everyone. Bye.
Bye.